My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 456. In this lecture, we will try to understand plots, calibration, scaling. So, one of the simplest technique to perform calibration is called plot scaling, also called as sigmoidal calibration. So let's understand the problem to be clear. So you have calibration data set, which is a set of y cap of I and yi. With a given y cap of I, we need to predict yi. That's the task, isn't it? So if you look at these plots, look at all of these plots, you will notice that most of these plots are actually looks like sigmoidal function. What is your sigmoidal function? This is my sigmoidal function. Look at this red line. Look at this red line. It looks like sigmoidal function, not like an exact sigmoidal, but they have shape of sigmoid. Similarly, not all of them, your green and red ones has nice sigmoidal shape. Your orange one, it's not following sigmoidal function shape. So, what people have noticed, especially Plot, a mathematician and machine learning scientist who worked on support vector machines a lot, has very interesting research work on SVMs. So he said, since these plots look like sigmoidal curves, these plots looks like sigmoidal curves very often, why can't we write just yi as a form of modified sigmoid of y cap of I, isn't it? Again, to be clear, these are what we got as, what is this? What we got as YQs from the model, isn't it? There are f of xq. These are f of xq. What is my YQ? That is my f of xq. And what are these? Yi means what? Probability of YQ equal to 1 given xq, isn't it? What is this? So plot scaling literally does this. Probability of YQ equal to 1 given XQ, it represents my YI is equal to, what is my YI is equal to? 1 by EXP of A into f of XQ plus B. In the place of f of XQ, what will I write? I will write y cap of I, isn't it? Yes, what is P of YQ equal to 1 given XQ? That is YI. The big question here is, what is A and B? What is capital A and capital B? Because rest of it looks like sigmoidal function. So what is capital A and capital B here? Now, the argument here is, given calibration data set, what is my calibration data set? DCAL calib. I will replace this probability of YQ equal to 1 given XQ, which is YI, isn't it? And I replace f of XQ. I will replace f of XQ as y cap of I. Just see, I am replacing this one. Just see this one. F of XQ I am replacing with what? Y cap of I. I just put these values here and I will try to find best capital A and capital B by solving an optimization problem. There are multiple ways to solve optimization problem, but we know how to solve optimization problem. We will just put yi value, isn't it? We will just put yi value, this one value as output, and we will put y cap of I, isn't it? Y cap of I in the f of xq. Because I have the data set, I will use the data set to solve the optimization problem to find optimal capital A and capital B. That's what plot scaling all about, and it is inspired by looking at lots of shapes like this, isn't it? But there is one problem here. There is one problem with plot scaling. Look at this plot. Just see, look at this plot. I want to explain this plot. This is basically an output generated by Gaussian Naive. What it is? It is output generated by GNB, Gaussian Naive model. This is actually a real world model. Now, if you look at the empirical model, what is this empirical model? This one, this block one, isn't it? Look at this empirical model, the actual data, this is my actual data. If you take data set, what is my data set? Decalib is y cap of y. They actually lie on this line, isn't it? Just see, they actually lie on this line, isn't it? This is empirical data, isn't it? Actually lie on this block line. That's why it is called empirical data. Empirical data basically means, so all my actual points lie on the block line, isn't it? Where can I find my points on the block line? First thing you notice is this block line looks like sigmoid. When your calibration plot does not look like sigmoidal function or sigmoidal like function in shape, what happens? Your block line here is the actual data. What is your sigmoidal calibration? Sigmoidal calibration is nothing but a plot scaling. In sigmoidal calibration is trying to solve the problem, trying to solve the optimal capital A and capital B. But what it's resulting in? It's a dark blue line, isn't it? Just see, a dark blue line which is way far away from block line, isn't it? The dark blue line is far away from block line. You can see that. Just see, it's far away from block line. So it is not doing good job. So plot scaling works if and only if your calibration plot looks like sigmoidal function in shape. Your block line here, it looks like stepwise function, isn't it? It has some, just see, it is just like stepwise function. Here if you observe this one, just see, here you have linearity, here is linearity. Again, it is just like a stepwise function. There is a fix for it. That fix is called isotonic calibration. What is the fix for this? Isotonic calibration, or I can say isotonic regression. Isotonic regression. Your problem is, just try to understand your block line. Look, your block line here, it looks like stepwise function, isn't it? It has some linearity, something like linearity, and it is just like stepwise function, this, isn't it? There is a fix for it. That fix is called isotonic calibration or isotonic regression. It is dark. It is dark green line, isn't it? What is this dark green line? Look at the dark green line. It is almost overlapping, isn't it? Just see, it is dark green line. This is isotonic calibration, isn't it? Look at the dark green line. It is almost overlapping with your data, isn't it? Which means it is very good at it. It is given a YQ cap, which is your f of xq. It is very good at predicting p of, it's very good at predicting p of yq equal to 1 given xq, isn't it? We are using decalibration data set of y cap of I and yi to achieve this. Given this point y cap of I, my isotonic regression which we'll learn in next lecture. Isotonic regression or isotonic calibration returns this value of this y cap of phi, return this y cap of I as, I can say, yi, isn't it? Just let me show that one. Yes, y cap of, what is this? We are using the decalibration data set of y. What is my decalibration data set? Just see this one. This is my decalibration data set, isn't it? Y cap of I and yi. To achieve this, given this point y cap of I, my isotonic regression, which we will learn in the next lecture, isotonic regression or isotonic calibration returns this value yi, almost value as yi almost all the time. Plot scaling or sigmoidal calibration is not able to in a nutshell, plot scaling or sigmoidal calibration is good if your data looks like red line, isn't it? If your data looks like red line or green line, it works very well. If it looks like block line, here, it works terribly. So we need to learn isotonic calibration, which is the most used. Isotonic calibration is the most used technique for calibration in the real world, and I have personally used it multiple times. Just go through this lecture. If you have any doubt, please keep a comment. Thank you very much.